Alright, today we're looking at lesson 3.1, solving linear systems of equations by graphing. And I've got the learning goal and the essential question up there. You can take a look at those and the standard up here. Okay, a system of two linear equations consists of two equations of the following form: ax plus by equals c and dx plus ey equal to f. A solution of a system of linear equations in two variables is an ordered pair that satisfies each equation, or we could say both of them. Okay, the first kind of problem that we're going to look at is pretty simple. We're going to check to see whether a given ordered pair is a solution to a system. So example 1, and go ahead and get this written in your notes. Check whether the following are solutions to the system. Okay, to do that we take the ordered pair 2, 2, and we got to plug it into both equations. It has to make both of them true in order for it to be considered a solution. So we're going to go ahead and check that. So plugging into the first one, we have 3 times 2 minus 2 times 2 equals 2. And let's see, let's work that out. 6 minus 4 equals 2. Subtract, we get 2 equals 2. It satisfies the first one, check. Let's see the second one. Is 2 plus 2 equal to 6? Does 4 equal 6? Well, 4 does not equal 6. So when we plug it into the second one, the ordered pair 2, 2 is not a solution because it doesn't make it true. So we can say that the ordered pair 2, 2, since it didn't make both of them true, it made one of them false, and it made this one true, but it has to make both of them true in order to be a solution to the system. So we would say, no, this is not a solution to the system because it didn't make both of them true. Just making one true wouldn't be enough. All right, let's look at B. So let's plug B in. We have 3 times 0 minus 2 times negative 1, and let's see if that's equal to 2, is 0. Now minus a negative, or excuse me, negative times negative is positive, so we have plus 2 equals 2. And 0 plus 2 is 2. We have 2 equals 2, which is true. Now, if we plugged it into the first one and it made a false statement, there wouldn't be any need to go on to the second one, because in order to be a solution to the system, we have to make both of them true. Okay, so since we get true, then we'll move on and try the second one. So plugging into the second one is 0 plus negative 1 equal to 6. Does negative 1 equal 6? No, it does not. This is false. And so we find that neither one of these are solutions to the system. Again, to be a solution to the system, you have to make both of them true. If you plug it into the first one and you get true, you go on to the second one. If that's false, the answer is no. If, by the other hand, you plugged it into the first one and got false, there wouldn't be any need to go to the second one, because since it has to make both of them true. Okay, well, let's go ahead and give a couple of problems. Let's try a few problems here, okay? Try this. Here's two ordered pairs. Here's a system. And go ahead and put this in your notes. Go ahead and check to see whether these are solutions to systems or not. Stop the video and go ahead and work these. Okay, assuming that you worked these already, we'll go ahead with this first one. Okay, so it's going to be 2 times 1 minus 3 times 4, and does that equal negative 5? Let's check. 2 minus 12 equal negative 5. Does negative 10 equal negative 5? Absolutely not. This is false. And since when we plugged it into the first one we didn't get a true statement, there's no need to plug it into the second one because it has to make both of them true. It has no chance to make both of them true. I know my answer is no, this is not a solution to the system. Let's try the second one. Plugging in. Okay, you guys are already telling me you made a mistake, Mr. Gibson, and I sure did. I plugged this into the second equation. So let's go back and plug it into this first equation again. Is 1 minus 3 times 4 equal to negative 5? Okay, so 1 in here, 4 in here. Okay, so is 1 minus 12 equal to negative 5? Is negative 11 equal to negative 5? Well, again, that's not true. So I'm through. I know my answer is the same as I got the first time, but I clearly didn't work it correctly. I didn't plug it in, kind of mixed up those equations there. All right, let's try B. All right, so we have negative 5 minus 3 times 0 equals negative 5. Well, does negative 5 minus 0 equal negative 5? I think negative 5 does equal negative 5. We have a true statement here. It does solve the first one, but it has to solve the second one to be the solution to the system. Let's plug it into the second one. Negative 2 times negative 5 plus 3 times 0 equals 10. Negative times negative is positive. 10 plus 0 equals 10. Does 10 equal 10? Yes, it does. It makes this true also, so clearly it's a solution to both of them. Therefore, it is a solution to the system, and we say yes to that one. Okay, all right, moving on to our next example. We're going to, this is sort of the meat and potatoes of this lesson, solving a system by graphing. So what we're going to do is we're going to graph both of these, and by graphing them, we'll be able to determine the solution. So take the first one, 2x minus 3y equals 1. And if we're going to graph this, we need to either put it in slope-intercept form or work it out with intercepts. And since 2 and 3 both don't go into 1, I wouldn't go with the intercept way. So we're going to put this in slope-intercept form. Slope-intercept form, for you that don't remember, is y is equal to mx plus b, where m is the slope, and all of this sign included is the y-intercept. That's where it crosses the y-axis. Okay, so we're going to do that. We're going to solve it for y. To do that, we'll subtract 2x from both sides. We get negative 3y equals negative 2x, and it's plus 1 because the 1 is positive, has to have a sign. We then divide everything by negative 3, and we get y is equal to negative divided by negative is positive, so we have 2/3 x. Make sure not to put the x with the 3 on the bottom. It needs to go out to the side. And then positive divided by negative is negative, and then that's 1/3. Okay, so let's go ahead and graph that. Well, my y-intercept is at negative 1/3. Okay, so I'm going to go ahead and mark my y-axis. Let's see, 1, 2, 3. Let's go ahead and make these fairly large since I want to be able to find 1/3 on there relatively easy. So you want a big unit if you're going to find a small fraction like 1/3. Okay, so we know that it crosses the y-axis at negative 1/3, so I'm going to say that's about right here. Okay, and then I use the slope to find another point. From the y-intercept, I go up 2 and to the right 3. Now, what you need to do is, basically we said we went 1/3 down from this line, so 1/3 down from this line is 1, 1/3 down from this line is 2, and I go over 3. 1, 2, 3. Okay, and we're going to put a straight line through those. If I can get this to work. All right, and let's work on the second one. All right, let's get it ready to graph. X plus y is equal to 3, and let's put this in slope-intercept form. Subtract x from both sides. We have y is equal to negative x positive 3. Okay, now when we put it in slope-intercept form, we need to see the number in front of x. Well, right now there's not a number, but it's a 1 if you don't see one. So negative x is negative 1x, and if we have to write it as a fraction, it's negative 1 over 1. Okay, let's graph this one. It crosses at positive 3, and we go down 1 and to the right 1. I'll do that a couple of times, and I'm going to draw my line. Okay, now let's take a second to talk about the points on the line. Okay, so in this first line, when we found these 2 points, they were definitely solutions to this equation. Basically, this line represents all the ordered pairs that'll solve this equation here, the first one. And we know that any point on the second line will solve any ordered pair on the second line will solve the second equation. What we want to do is to solve both of these at the same time. So what we're going to look at is where they intersect. There's a point that lies on both lines, and so it must solve both equations. So let's take a look. I think this point right here looks like it's 2, 1. Let's take those back and plug those in. What is 2 times 1 minus 3 times, let's see, I'm getting this wrong. Okay, it's 2 times 2 here. Let's try again. What is 2 times 2 minus 3 times 1? Does that equal to 1? Does 4 minus 3 equal 1? Yes, 1 equals 1. So clearly it solves this one. Let's plug them into here. And is 2 plus 1 equal to 3? Does 3 equal 3? Yes, it does. Clearly, it makes both of these true. And it's the solution to the system. So the solution to this system of equations is 2, 1. Okay? Let's let you try one of these. Go ahead and solve this system by graphing. Okay, assuming you've already done that, let's go through these one at a time. So let's take 2x minus 2y equals 8 and get it ready to graph. Well, notice that 2 and 2 both go into 8 evenly, so it might be good for us to use intercepts. I think it might be the easiest way. Let's just try something different from slope-intercept. Okay, so reviewing graphing with intercepts. If you want to find the x-intercept, you let the y value equal 0. When you let the y value equal 0, basically that y term falls out of the equation, and what's left is 2x is equal to 8. Well, we can divide by 2, and we know that the x-intercept, or where it crosses the x-axis, is 4. And the y-intercept, you just let x equal 0, or it falls out of the equation, and what you get is 2y is equal to 8. Divide by -2, and y is equal to -4. So this crosses at -4 and at +4. And let's draw our line through those 2 points. Okay. All right. Go to the second one. Let's get it ready to graph. 2x plus 2y equals 4. Hey, intercepts look good to me again here, so let's do them. X-intercept, 2x is equal to 4. Divide by 2, and x is equal to 2. Y-intercept, drop the x out, and 2y is equal to 4. Divide by 2. Y equals 2. So it crosses at the x-axis at 2 and the y-axis at 2. And we'll draw that line. Okay. And now our attention is drawn to the coordinates of this point. Okay, given the fact that this is a sketch and this is really not graph paper, we can probably assume integer coordinates for this. So I'm going to say that this is probably going to be 3, -1. Now if we had graph paper, and certainly on a test or quiz, you would be provided graph paper so that you could tell absolutely sure, but I'm going to say that that's what I think the answer is. Now let's plug it in and see if it works. What is 2 times 3 minus 2 times -1, does that equal 8? Well, 6 and then negative times negative is positive. 6 plus 2 equal 8. Yes, it does. It solves that one. And let's try this one here. 2 times 3 plus 2 times -1, does that equal 4? Is 6 plus -2 equal to 4? Yes, it is. So clearly, the solution of the system is the ordered pair 3, -1. Okay, next kind of problem. Okay, example 3. Tell how many solutions the linear system has. Okay, so to do this, we're going to have to graph them. And so let's get these ready for graphing. Let's look up here. 3 goes into 6 and 2 goes into 6. Let's use x and y intercepts here. It's the easy way. So we get 3x is equal to 6, or x is equal to 2 when you divide by 3. And the y-intercept is negative 2y equals 6, and divide by negative 2, and y is equal to negative 3. So 2, negative 3 on the y. And we graph it. All right, and now the second one. 4 goes into 12, and 6 goes into 12, and so does 4. We can use the intercepts on these too. I like intercepts when they work. It looks like they'll be pretty easy. So 6x is equal to 12, and divide by 6, and x is equal to 2. And then the y-intercept, negative 4y equals 12. Divide by negative 4. And y equals negative 3. So y, that's the exact same line. It crosses here and here. I draw the line through that. Well, let's think about this for a second. On that last problem, didn't we say that the solution was where they intersected? Well, when I draw this line on top of this other line, every point is going to be an intersection. How many points are on the line, class? As if you could answer me. An infinite number of points on this line. Since these are basically the same equation, this has an infinitely many solutions. That's what we say. Okay, infinitely many solutions. All right, let's take a look at this one. B. Can we do intercepts? Looks like we can. 3 and 2 both go into 6 evenly, so 3x is equal to 6, x is equal to 2, negative 2y is equal to 6, y is equal to negative 3. It seems like I've seen that before. Not getting very creative on these answers or examples. Let's draw that line in. Okay, go to the second one. We can use x-intercepts here as well. The x-intercept, well, let's see, maybe not. I don't really like the way that's looking. They don't go, actually they're not given to intercepts. Let's go ahead and put it in slope-intercept form. Let's subtract 3x from both sides. We have negative 2y is equal to negative 3x plus 2. We divide everything by negative 2. And we get y is equal to 3 halves, negative divided by negative is positive, 3 halves x minus 1. Okay, because positive divided by negative is negative. 2 over 2 is 1. So this one crosses at negative 1, goes up 3, and over 2. And let's draw that line in. Okay, sort of know how this is supposed to turn out here, so I'm going to adjust this a little bit. 3, 2 would probably be more in this area here. And if you're thinking that these lines look parallel, that's exactly right. How can you tell if two lines are parallel? Well, they have the same slope. How do we get from this point to this point? Go up 3 and over 2 to this one, go up 3 and over 2 to this one. M here is 3 halves. M here, the slope here, is equal to 3 halves. Lines that have the same slope are parallel. What do we know about parallel lines? They never intersect. Well, we're looking for where the lines cross, or where what the points that they have in common. If they never cross, they're never going to have points in common, so this has no solution. Okay? So infinitely many. We can have infinitely many, we can have no solution, we can have one solution. All right, let's try one of these. Give you some time to do this. get them ready to graph. You know, I'm going to go ahead and put both of these in slope-intercept form. So I'm going to start with this bottom one. So I'm going to subtract x from both sides. I get 2y equals negative x and a positive 6 or plus 6. And divide by 2. I'm going to put a 1 in front of that x, so I have a numerator of 1. Dividing this by 2, I get y equals negative 1/2 x plus 3. Okay, let's do the same thing with 2x plus 4y equals 12. Subtract 2x. Now I know I could graph that in slope-intercept form, but I want to see something. I've got a hunch here. You probably do too. So that's what we get here, and we divide by 4. Not liking the way that's turning out. Oh, that's a 2x, not 3x. Let's go ahead and do a little racing here. That should be 2x. And divide everything by 4. And we get y equals negative 1/2 x plus 3. Now, clearly these are the same equation, just in different forms. If we graph one line on top of itself, every point is an intersection, and we get infinitely many solutions here. Every point is an intersection. There's an infinite number of points. Let's put these in slope-intercept form. Here I'll subtract 2x from both sides. I get negative 2y equals negative 2x plus 9. Divide by negative 2. I get y, and I'm going to write it up here, y equals negative 2 over negative 2 is positive 1. A negative divided by, a positive divided by negative is negative 9/2. Okay. All right, let me go ahead and erase this here. Get a little more room to work the second one now. Make that eraser a little bit bigger. All right. And now let's take this one and put the top one in slope-intercept form. So we have x minus y equals 5. We subtract x. Negative y equals negative x plus 5. Divide by negative 1. Well, that's getting sloppy there. And we have y equals positive x minus 5. Y equals x minus 5. Okay. Move this out of the way. What's the slope on this one? Be 1 or 1 over 1. What's the slope on this one? The same, 1 over 1. Now we can graph these, but these have the same slope but different y-intercepts. Well, that's exactly what parallel lines are. We'll take a look and see. Okay, so this one crosses at 9 halves, 2 halves, 4 halves, 6, 8, 10 halves, crosses at 9 halves, and goes up 1 and over 1. All right, this one crosses at negative 5. Goes up 1 and over 1. And I think you can see we're looking at parallel lines here. Okay, and so this one would have no points in common, so no solution to the system. All right, next will be the homework assignment, and I'll put that up after the video ends.